Right, let's look at the homework 8.3, problem number 8. Right, first we want to evaluate this function f of x equals sine of 4x over sine of 5x for these various values. Right, so let's do that. Alright, so I'm going to use GeoGebra, so I'm going to bring up GeoGebra, right here. And let's define function. So in the input box, we're going to type in f of x is equal to sine of 4x divided by sine of 5x. Right, then hit enter. Right, so we have this function here. Right, then we want to evaluate at x equals negative 0.1. Right, so let's do that. So f of negative 0.1, then hit enter. Alright, so this is correct to the 4 decimal places, but if you want to change the rounding, you can actually go here and choose whatever the decimal places you want for this problem, 4 decimal places. So click on that, then you get that. Right, so it's 0.8123. So 0.8123. Right, how about the negative 0.01? Right, so type in f of negative 0.01. Right, then hit enter. Right, so we get 0.8001. Right, 0.8001. Right, and how about negative 0.001? Right, so let's try that. Right, f of negative 0.001. Right, then hit enter. Right, so it became 0.8, I guess 000. Right, and how about the positive 0.001? Right, so we have f of 0.001. Right, again we get 0.8000. Right, how about the 0.01? So you have f of 0.01. Right, then you have 0.8001. Right, then the last one 0.1. So f of 0.1. Right, then hit enter. Right, so we get 0.8123. Right, 0.8123. Right, but you can see that as x value gets closer to 0, it is getting closer to 0.8. So my guess is this is going to be 0.8 or 4/5. Right, let's submit for testing. Alright, it came back and looks like we got these guys correctly. Right, but I would like to show you how to do it by hand or algebraically. Right, alright, so we want to evaluate the limit of this function sine of 4x over sine of 5x as x approaches 0. Right, remember that we have one of those useful limits. When you take the limit of sine of theta over theta is equal to 1. Also, if you take the reciprocal, say limit of theta approaches 0 of say theta over sine of theta. Right, but this can be rewritten as limit sine, 1 over sine of theta over theta as theta approaches 0, right? Then we know that this guy right here from this first limit approaches 1. So we know that this guy is going to 1 over 1, which is 1, right? So either way, you're going to get 1, right? Let's tweak this guy a little bit. So how about this? If you do limit, right, and x approaches 0, right, then I'm going to split this fraction into two fractions, right? One of them, I'm going to put the sine of 4x on top, right? So that's this guy. And I'm going to put sine of 5x on the bottom of the other fraction, right? So far, nothing really changed, right? So in order to use this limit, we have to have the same thing over here, same angle in a way. So we would like to have 4x here. So I'm going to put the 4x. Right, but if you divide by 4x, make sure to remember to multiply by 4x so that we don't change the quantity. Right, then here, in order to use the other limit, we would have to have a 5x here, so we have to match the angle. So if you multiply by 5x, you would have to have a 5x on the bottom to cancel it out. All right. Then you can see that we can clean up a little bit. So here, x and x cancel out, right? But this guy right here, this guy, as x approaches 0, we know that the sine of theta over theta, which is exactly the form, so this is going to go to 1, right? And this guy is the same way. This is basically theta over sine of theta. This guy approaches 1, right? So what we have is 1 times 1 times 4/5. So therefore, the limit is 4/5, right? Which is the same thing as 0.8, which was our estimate from the table, right? That's it. So this is how we can find it algebraically, right? That's it. I hope that this was clear.